Data engineering is the software engineering that enables data scientists to work effectively. At least that's one way of putting it. In today's episode, we explore the different sides of data engineering, the data science algorithms that need to be processed, and the implementation of software architectural patterns that enable those algorithms to run smoothly. The PANCAKE Stack is a 12-letter acronym that Chris Fregly gave to a collection of data engineering technologies, including Presto, Cassandra, Kafka, Elasticsearch, and Spark. It's kind of hilarious. In this episode, I asked him to name the acronym, and he couldn't actually remember all the things in the stack. I think it's a bit of irony. Because in his current life, Chris travels around the world giving workshops on how to deploy and use the technologies in the PANCAKE Stack. It's really more of a superset of the technologies that you might need. It's just a wide collection of technologies you could build your data engineering stack with. Before he was doing these workshops, he was an engineer at Netflix, where he actually received an Emmy for streaming engineering excellence. It's a really great episode. I greatly enjoyed talking to Chris. We had a great conversation about data engineering, the state of data engineering, all these different technologies and how they fit together. A really wide-ranging conversation, too. I think you're going to really enjoy it. The Insight Data Engineering program helps software engineers level up their careers. Data engineering is at the cutting edge of how we build software, and it involves some of the most interesting open source and distributed technologies, such as Apache Spark, Kafka, and NoSQL databases. Insight Data Engineering is free because they partner with top companies like Facebook, Uber, Capital One, and Slack. You can learn about data engineering at Insight Data Engineering. And if you go to insightdataengineering.com/sedaily, you can apply. Listeners of this show will be advanced straight to the coding challenge of the application process. If you get accepted, you get to learn how to build useful products in a self-directed program. There are workspaces in New York and Palo Alto that you can utilize during the short 7-week data engineering training process, and you have access to free cloud computing resources and a network of over 600 data engineers and data scientists from over 100 companies. Apply now at insightdataengineering.com/sedaily. Skip straight to the coding challenge. This is a special offer for Software Engineering Daily listeners. Thanks to Insight Data Engineering. And if you want to level up your career, if you want to learn some new skills and change what you are working on in your work environment, and perhaps get a job upgrade if you're looking for a different type of job, or if you're between academia and your career path and you want to build a little more skill before you jump on that career path, learn about data engineering at Insight Data Engineering. Go to insightdataengineering.com/sedaily to apply and skip straight to that coding challenge. And thanks again to Insight Data Engineering for being a new sponsor of Software Engineering Daily. You can also check out the interview I did with Insight Data Engineering several months ago on Software Engineering Daily. Let's get back to this episode. Chris Fregly is a research scientist with Pipeline.io. Chris, welcome to Software Engineering Daily.
Hey, man. Thanks a lot. Yeah, thanks for having me.
So you worked for several years at Netflix, and I want to start with some discussion of what you experienced with machine learning at Netflix. Netflix is obviously well known for its machine learning capability. And then we'll get into a conversation about architecture and what you are thinking about data pipelines today. So why don't you just give me an overview for what you worked on at Netflix and what things you saw in terms of machine learning.
Yeah, so I mean, the reason they're so well known, for their machine learning specifically, is just the amount of data that they collect, right? The big joke is that they're a logging company that just happens to stream video, also, right? So they capture pretty much everything going on. They capture all the data from the devices, and they merge that with so my team was the streaming team, right? And then getting that data into the machine learning pipelines and and seeing, so sort of end to end, getting all that data in and then serving it back up. So, it was just the scale and quantity of data going in there, and then working with the data scientists to actually mine it and make something useful, right? Like mainly recommendations, of course.
So when you were working there, was there a lot of was there a bigger community outside of Netflix where people were talking about these kinds of problems, this data streaming type of problems, or was it more of an insular type of, you had Amazon over in one corner, Netflix over in one corner, Google over in one corner? I mean, today it's obviously huge communities, but was it more insular back then?
Yeah, that's a good question. This was 2010, 2011. It was, I remember having lots of calls with Amazon, but it was more about the cloud infrastructure and can we get, 5,000 nodes, which was sort of unheard of at the time. Just making sure that, they could keep up with us during peak times, right? Like after the Oscars, things like that. So I don't remember discussing too much with them about the Amazon, the machine learning side of things. We definitely fed off of a lot of their papers and some of their item-to-item collaborative filtering stuff. That there's a famous paper from them, I think in 2003, how they basically couldn't scale the user to item, type recommendations, type. And so they started doing more like item-to-item similarity type stuff. And so there was a lot of that going on, but not really direct peer-to-peer. It was more just us kind of picking up papers and figuring out, what these other groups are doing. Spotify also has, I think towards the end of my Netflix days, we were starting to kind of take cues off of them. Those Spotify guys do a lot of stuff. This guy, Chris Johnson, has a couple good presentations and papers and things like that.
With the Spotify, for example, it seems like that's a really great opportunity for information sharing because you're kind of working on the same problem in disjoint domains. Is that accurate, or was there any bottlenecks to information flow between the companies? Yeah,
and most times that we would see those guys, I mean, it wasn't, us sending them emails directly or anything like that. It was more, we're pretty active still are. Those guys still do present quite a bit, Netflix and Spotify, at conferences, right? So these conferences seem like they're kind of fluffy and all that, but there's a lot of stuff going on back in that speaker lounge, and that that's something I realized when I started speaking. I'm like, this is kind of a whole separate group of people that you start to interact with, and you just go to each other's sessions, and you can't usually get to them right after because a million people go up and talk to them, but you'll see them in the lounge or see them walking around and say, hey, that was a great point. I'm gonna start pulling some of that stuff into our flows. Like Uber, they've been kicking butt recently with their pipelines, and so they're actually building.
I love how open they are.
Yeah. They're open on some things and then closed on others. So I've come to realize this.
You definitely can't ask them. So how does that surge pricing thing work?
I think there's some sessions too where they've said no to the cameras and things like that. So I'm not quite sure what their restrictions are specifically for speaking, but you can sort of glean from what they're presenting on, and I don't see a whole lot of it make it out into the open source world. I mean, it's probably one of those things, just like Netflix when they were first building all this stuff, it wasn't, really open source ready. You kind of have to sit down and refactor everything and clean up all the code.
Totally. Well, they open sourced RingPop, and it's like this. I don't know if you've looked at RingPop at all, but it's like this thing that is. Upon first looking at it might be like, wow, how the heck would I apply this to any problem except Uber? And I'm sure it's going to be something that will be broadly applicable in the future, but it's one of these things where the reason they had to roll their own thingy is because Uber faces challenges that are quite unique to Uber. I imagine the same was probably true for Netflix in the earlier days of the streaming data pipeline.
Yeah, for sure. Yeah, I'm just checking out RingPop here. I actually was not aware of this. Yeah, I mean, specifically Netflix, we were, pioneering things within Amazon, and things like middle tier load balancers, that were not public, right? Like all the old like original load balancers, the like ELBs and things like that. Yeah, right. So they were always public. So we needed a way to do service discovery, really internally, and that's where projects like Eureka like came about. That's the like sort of internal load balancer like service discovery stuff. So
Sure.
most of that stuff these days, like is pretty much just used. I think by Netflix, like I know a couple other projects have made it out, like Hystrix, which is the circuit breaker. That can be used anywhere basically. But some of the service discovery stuff, there's a lot simpler ways to do it, and some of the really really high scale things, like if an entire region goes down, right, like that's handled by the Netflix Eureka, but really not a lot of people have those issues, so or really care to solve those issues right now anyway.
So I think there are like two angles that I think are interesting to discuss in terms of your work and what you are evangelizing these days. I think there's the discussion around the algorithms that you use to do machine learning and to do scalable machine learning, and these different ensembling strategies, these strategies of combining different machine learning recommendation strategies that have been around for a while. There's also the conversation around all the different technologies that you can use to implement these algorithms. So I want to like talk about both of these different areas and maybe jump back and forth between them so listeners can hopefully get a feeling for the connection between these two sets of discussions. You mentioned that Amazon paper around collaborative filtering, how collaborative filtering, I guess, could not scale at a certain point. And this is one thing I like about your talks is you have these different anecdotes about these discoveries that have come out in the last 10 years and these papers and things like that. Just as an example, because I think it's I got interested. You were talking about it. What was Amazon doing that didn't scale, and what did they write about in that paper? Because I actually haven't read that. I read some of the Dynamo paper, and that's a really good one. But maybe you could just tell that anecdote about what Amazon was doing and why it didn't scale.
Yeah, I mean, I think the gist, and I'm just pulling it up here just to kind of like remind myself. The general gist of it was their product catalog wasn't increasing that much, right? But like when I joined Netflix, for example, there were only 30,000 movies, but there were 20 million customers, right? So with Amazon, so that was 2010. They were dealing with this back in 2003, where their sort of the columns in your matrix factorization were steady, so skinny, and then it was just growing, down, I guess the y-axis down the rows for the number of users. So what they realized was that they could actually simplify and start to make recommendations between items, right? Like versus using the collaboration between user and item. You could sort of start to do similars, between items and sort of cluster items and things like that. So the second benefit of that, besides the actual processing, it's like less processing time, less CPU time. Because what was happening was these matrix factorizations were taking, more than 24 hours, right? And so it couldn't really keep up with when users would log back in. And so the second benefit for the item to item is that you can now start to surface, stapler and staples and some of the not so obvious things based on just metadata, right? So the name of the paper is Amazon.com recommendations, item to item collaborative filtering. So this is the first time where, because most of the time you think of user to item collaborative filtering, but this is actually item to item.
So the idea is that you have instead of just taking users and looking at user bought user A bought a stapler and also bought staples, and user B bought a stapler, we should recommend staples to user B. You can just look at stapler and then look at some features within that product, or however the product is enumerated, and then you can also do a comparison. You can compare the stapler matrix or vector to the staples vector, and you will find enough similarities that it makes sense to recommend the staples to the stapler browser, or whoever is purchasing a stapler.
Right.
Yeah, so I think it's interesting because you talk about these similarity calculations that you have to run because in any of these types of operations you have to vectorize the unit that you're talking about, whether you're talking about a user or you're talking about a product, you're talking about a movie. All of these things have to, so if the listener is not super familiar with machine learning, all of these things have to be turned into vectors so you can basically do these numerical calculations in Cartesian space. And it's interesting because you talk about how to do this at scale, because if you need to run it, for example, in the products, if you need to calculate the closest recommendation between stapler and all other products, that is an infeasible thing to be doing at scale. So you have to do these, for example, approximation strategies to be able to speed up this type of comparison. Can you talk about that a bit? What are these approximation strategies? How do you do this type of collaborative filtering or just vector comparison at scale?
Yeah, so once you actually have the vectors, the sort of naive brute force way would just be to compare, right, like each item to all the other items, right, and then surface the top 100 for each item. Yes, obviously that's Cartesian. For 30,000 items, that's not too bad, but when you start expanding, right, like beyond that, things really get pretty hairy. So there's these techniques. The most common one that we see, I saw this at like Databricks quite a bit too when I was working with them. There were like lots of customers coming to us that once they could get to all their data within Spark, like now they wanted to find similarities. So they first would like vectorize everything, right? So each item they could represent with some vector of like doubles, and then but they very quickly would just kill their Spark cluster, or they would, go from 8 nodes to 16 to 32, and it was taking hours and hours to do this huge Cartesian. So you can essentially do one pass through all of the items and bucket them, right? And there's, so that's the sort of intuition behind LSH, locality sensitive hashing. That's the main one that we see.
So rather than doing a full comparison, you do just like you throw them into buckets.
Right. And then you do full comparison within each bucket. So the sort of intuition is that you do one pass through. There's a Twitter, what's the library? Algebird. Yeah, so Twitter Algebird has this built in. And actually, I have a couple demos off my GitHub repo, the Flux Capacitor GitHub repo, that shows locality sensitive hashing, and I'm using Twitter's Algebird. And there's this technique called min hashing. So you go through and for each item create a min hash signature, and you give it the number of buckets right beforehand, and it's going to go through and so there's two benefits to that. You sort of decrease the size of each bucket, right? So, which is then going to be passed into Cartesian. So per bucket, those items get compared Cartesian-wise, right? But those buckets are much, much smaller. And then if you only have 50, so let's say that you can simplify it down to 50 buckets. Now you can do all 50 in parallel. If you have 50 nodes, for example, 50 worker nodes on your Spark cluster. So the overall computation goes down. It's a little tough to sort of validate, really how many buckets, and you sort of have to eyeball it from a human standpoint when you get the results. That's the downside of any kind of clustering or any sort of approximation stuff is not unless you actually do spend the time to run the full brute force. Can you compare it and say, okay, I was within this much confidence value from the exact. Yes, if you were doing right, like cosine similarity, for example. So that's typically what you would do if you had a vector and just did brute force. You would use cosine similarity in this vector space.
So this hashing strategy, this bucketing strategy, how are those buckets made? What are you doing the hashing? Like, what are you hashing the components based on? And
exactly, So what you're doing, I mean, you could feed in, so let's see, how does my demo do it here? You could basically feed in anything, right, to it and say, so I'm just giving it the raw vectors, I'm actually rolling my demo server because I have a workshop tomorrow, so I'm making sure everything. So my demo's not up right now, but you can feed it like essentially any sort of set of features, and then it's going to crunch that and basically hash it. So you can provide the number of buckets. You can provide. What's the other? Let me just pull up Twitter's algebra here.
So are you saying that when you run this hashing function on each of the different vectors, they will get bucketed, or the output of the hash function will be similar to across each other, and so they will get bucketed similarly?
Yeah. So the features that you pass in, the more similar they are, and each item can end up actually in like multiple buckets as well. So that's the other key, is that it's not like an exclusive single bucket output.
Fascinating. So just out of curiosity, can you just do some kind of similarity matching between the output of the hashing function? Is that useful at all, or do you need to do the feature by feature comparison of the vectors?
No. So you would bucket. Yes, I see what you're saying. So once it's bucketed, could you just return like whatever's in the bucket, right? Yes, I suppose you could do that. It would be pretty coarse grained.
Right, pretty coarse.
That's actually interesting. I haven't taken a look at the specific output of the buckets. I typically just pipe it right into the Cartesian brute force within bucket.
Sure.
But
okay,
that would be a
interesting experiment.
Mm-hmm.
So I'm curious about something else at Netflix, because we've done a couple shows about this Netflix data pipeline. I think they call it Keystone. Mm-hmm. And it's evolved from version 1 to version 2 to now version 3. How much of that pipeline were you at Netflix for, and how have you seen that pipeline evolve? Yeah,
it's funny because I was there right around the beginnings of 2.0 and 2.5. The big shift was moving away from Chukwa, right, which was kind of like Kafka, sort of like an older version. So Netflix had a couple committers on the like Chukwa project. So just seeing that put into place, like Kafka getting in there, and then right now they're still using Samza, just because Kafka plus Samza is a pretty powerful combo. That's what like LinkedIn uses, and I believe Netflix actually hired someone from like LinkedIn fairly early on. I think around the 2.5 to 3.0, which is Keystone days. So they just kept that combination in place. They've been trying Spark streaming here and there, but it's pretty heavy Samza right now for like a lot of the supercritical log collection.
What about Kafka Streams? I guess this is getting into the architectural side of things, but we had a show recently about Kafka Streams. Do you know if you can get the functionality that you would have wanted out of Kafka plus Samza from just Kafka and Kafka Streams?
Yeah, so I was at Strata this week out here in like New York, and there was a lot of Kafka talk, a lot of Beam talk too as well. Not sure if you've been paying attention to that.
Oh yeah, I did a show about that.
Right on. Yeah. It's funny because we're starting to see more and more Google guys come out of, behind the Google firewall and starting to talk. And they've got a lot to say, man. And yes, I talk to them quite a bit because I know a lot of the TensorFlow guys over there and a lot of the just right, like Beam guys and all that, but they looked worn out by the end of it because they were doing workshops, they were doing, the like AMAs, Ask Me Anythings. They were, just yeah. So Kafka Streams is pretty interesting, and actually, sort of related. I haven't seen too much with Beam and Kafka Streams. So someone
is
asked,
it Beam compliant?
I don't. You know what? It would depend on if there's a runner that's built for
right.
it, and I don't think there is. And sort of interestingly enough, the Spark streaming runner was built by Cloudera. Not really seeing too much support from the Databricks guys on that. My hunch is that they're spread a little thin. That was my feeling back when I was there. Is that the open source side of things is pretty fixed, and they're sort of growing on the product side of things, but so they don't have a whole lot of time for a lot of these sort of auxiliary projects and things like that. But
well, if I were any of these cloud provider companies like Cloudera or Databricks, I mean, maybe this is paranoia, but I would be quite paranoid about the whole Beam thing and be like, oh my God, Google is gonna take all of my business.
Yeah. Wow. So one thing I actually heard this week, this is actually more related to the like TensorFlow stuff, but for TensorFlow distributed, they have a Mesos. So it's been pretty heavy Kubernetes, right? So those projects have, so Beam, Kubernetes, and then TensorFlow are the three big projects that.
Yes.
Yeah. So Google's been representing, and they're all sort of connected, right? Like definitely. Like TensorFlow and then Kubernetes, but now they're coming out with a Mesos schedule orchestrator as well. So, and that's coming out of Google plus the Mesosphere guys. So they're starting to kind of open up. They said a Yarn one might be in the works. They don't really have too much input on the Yarn side of things, but I think the Mesos one is going to come out pretty soon. But yeah, man, this Beam stuff, I mean, it's a good play by Google, right? They want people to start using their cloud platform, and what better way than to open source some of these key technologies and get people interested, and yes, oh, by the way, it works best on Google Cloud. Yeah, very clever. And one thing I'm starting to notice, they have a pretty limited developer advocacy group, and I think all this stuff kind of hit them all at once, where literally, down to the O'Reilly Media people, yes, they're having problems finding people to do TensorFlow books and, video series, things like that. It's just tough to get these guys, right? I mean, I've been trying to get them to come speak at my meetup, the Advanced Spark TensorFlow meetup in San Francisco.
Sure.
And they're scheduling out till April and May of 2017 and stuff. So
wow.
Yeah, and that's a sort of maybe, So it's always the same people that I see at these conferences and these meetups and things talking. So I think they're spread pretty thin too, and maybe weren't prepared for a lot of the open source community, type evangelism. I think before maybe they were just doing a little bit of light cloud, developer advocacy, but. Yeah, they're starting to pull some of these engineers out, and these guys just want to code. Yeah, that was my impression after Strata this week. I was talking to them. They're like, "Yeah, I'm so far behind on my milestones for this week and stuff." So, yeah.
Yeah, I mean, the question I was trying to ask I did a couple shows with Dataflow people. I had Tyler.
Yeah.
No, not Tyler. Sorry, Francis Perry and. Eric Anderson on the show, and we were talking about Dataflow and Beam, and what I didn't understand was if you're gonna run a Beam compliant streaming workflow, why would you have it run on anything other than Dataflow? Why would you have it run on Flink or Spark Streaming or whatever else?
Yeah. What's tricky too is, Spark Streaming doesn't implement all of those, and I think it depends on the person building the runner, right? Like the adapter, to sort of shim, some of those features like the triggering and the windowing and And yeah, actually, there was a Flink demo this week as part of the Beam workshop that I attended. There was a Flink guy, right, like Jamie Greer, who's in San Francisco. He's sort of the data artisan, right, like liaison, came from Twitter. But yeah, there was this bug that was in the Flink runner that like essentially like disabled triggering, and we couldn't figure out how. Right, like, yeah, I mean, no one found this, so just kind of weird things pop up. But yeah, you're right. I mean, it sort of gives you the illusion that like you can switch from one to the other, but I mean, really, like you're going to choose the one that supports all the features and yeah, has the best integration with the sort of master spec. Yeah, the Beam spec, right?
Well, anyway, we should obviously get back to stuff more related to what you're talking about. But I love talking to you about this.
Yeah, I mean Kafka Streams. Yeah, so back to that. I talked to quite a few people about like Kafka Streams, and really people want to use Spark streaming because of Spark ML, and they already have a lot of stuff, the Spark ETL, and yeah, like, yes, I don't want to learn a new API. This is the same with Flink as well, right? Like, why would, if Spark streaming is not the best and Flink has complex event processing and right, like that kind of thing.
Well, Kafka Streams, it seems like it's really good for these like streaming just table updates.
Yeah.
Which is that seems like a slightly different domain than
and joining streams and
right,
yeah. Mm-hmm.
which seems far removed from doing machine learning.
Yeah, the iterative, right, like the incremental. Yeah, and I mean, yeah, even Spark Streaming plus Spark ML doesn't really do the incremental like machine learning. There was one talk, one of my old coworkers at Databricks, and I pulled her into the Spark Tech Center at like IBM just recently too, about a year ago. So Holden, right? Like, do you know Holden Crow?
Yeah, she was on the show.
Cool. She actually did a really good talk. Her and my other old coworker from IBM, this guy Seth, they did streaming machine learning, and they basically had to hack, and this was all based on Spark 2.0, so it's right, like the latest code base. They had to hack Spark streaming, they had to hack Spark ML, they had to do some weird stuff with data frames and data sets, and so there's quite a bit of work, and I think they submitted a pull request, but it's kind of just sitting out there. So yeah, I know firsthand Databricks is planning to sort of beef up on that area, but yeah, they have to stabilize streaming first and get structured streaming built, and then they can start doing the incremental, really online training and online serving, which is really, really hard.
Yeah, and that's what you're concerned with, right? The online serving stuff. That's what so I mean, these machine learning workshops they're giving, or well, I don't want to say machine learning workshop, but these workshops on these data pipelines.
Yeah. A
lot of the idea is that it is this production model thing, right?
Yeah. So like we're using Redis. I'm essentially following the Netflix paradigm here for that. So yes, everything from the ability to scale out the serving, right, like the whole serving layer. I'm using Netflix OSS for that. I'm using Redis. There's this project by the Netflix guys came out, I think the end of last year. It's called Dynamite. Yeah, have you heard of this?
I have not heard of that.
Yeah, it's pretty cool. Like you mentioned Dynamo Paper earlier, right, like by the Amazon guys. They essentially built, right, like Dynamo, but yeah, so now, right, like you can plug in Redis, you can plug in Memcache, and so, right, like they basically wanted the same semantics that they have with Cassandra and with like DynamoDB and that kind of thing, but with these like just like massively, right, like in-memory caches, right? So this is how Netflix serves things up. They do all the offline generation and then just push these huge maps into these Redis and like Memcache tables, right? And there's some work going on with like RocksDB where people that are not active kind of get saved out to SSD to free up memory for, right, like the actual active people. But and it's like the first iteration was just push out all of the generated data out to really all these servers, but that was starting to get pretty expensive. So. But yeah, Dynamite gives you the whole CAP theorem, right? So yeah, you can tune the consistency based on your use case.
Continuous integration is so useful that I've started using it on my own personal projects. Snap CI from ThoughtWorks has the fastest setup I've ever seen. I registered for Snap CI with my GitHub account, and after a few clicks, I had continuous integration pipelines set up for a Node.js application and a Rails application that were just sitting on my GitHub account. And I don't want my users to experience breaking changes, so I want to run a large suite of tests for my application every time I push a change. And SnapCI will run those tests quickly, in parallel, on a worker that SnapCI spins up and takes care of for me. Whether you have personal projects like me, or you work at a company that is looking for the perfect tool to improve the deployment process, go to snap.ci/softwareengineeringdaily. SnapCI embodies the lessons that ThoughtWorks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. It would support Software Engineering Daily, and you would get to check out continuous deployment. snap.ci/softwareengineeringdaily. Thanks for listening. So, talking more about what you are doing in these workshops, why don't you just explain what is the goal of these workshops? What happens during them? Like, who is coming to these workshops? Because I was just looking at your page, and it's like they're selling out. Like, people are just going to these workshops like crazy. Like, clearly, people actually want to learn about how to serve production users with machine learning data.
Yeah.
Why don't you just walk me through what goes on in these workshops?
Yeah, I mean, just to sort of back up, why I even started doing this and, made this stuff public. I tend to just kind of tinker around a lot. And, let's see. When did this? I think this started last August. I was working with a couple guys in San Francisco to build out sort of a reference implementation of the SMAC stack, right? Spark and Mesos, Akka, Cassandra, Kafka. And the
acronym kept growing.
Yeah, totally. So PANCAKE STACK. Yeah, I somehow worked in the word stack in there as well because I just had so many technologies. And so, right, like the way I describe it is that this is my playground, right? And I showed someone this and they said, hey, yeah, this would be perfect for this Mac stack. Why don't we use this? And I'm like, all right, cool. And so we had to add, diagrams and sort of steps around it. So that was the very, very first sort of iteration. And then from there, I just wanted to sort of build out and get the serving layer back in there. So, get Redis. And I was just going back through all the old, right, like Netflix, blog posts and talking to my friends there and, right, like, how you guys doing it now? What's different? So the goal is just to sort of expose people to these different technologies and, right, like, where they fit in. It's tough because with so many people coming, I mean, these workshops, I think the biggest one was like 120 people. We had 2 projectors. We had like 10 TAs running around helping people. It was pretty fun. And people that know Kafka don't want to hear about Kafka. They want to hear about, TensorFlow, right? So it's tough to sort of go down the middle, in these workshops. Everyone's always mad at me for something or like disappointed about something. So it's just something I've had to deal with. But it's to get people to think too more about the production serving side of things, right? These things are difficult, right? Like a lot of data scientists I talk to don't know what happens after their pipeline ends, right? Like their version of production is, running it in this notebook, getting a model, and then, right, like the old hand it over the wall to the like production engineer or data engineer or whatever.
So a listener to the show named Don Janja or Hanja, I think, I don't know. He was the one who recommended I email you and set up a show. So thanks to him.
Cool.
But so he said that I guess what goes on in the workshop is there's a big Docker image with all of these different technologies. And at the beginning, I guess everybody gets to pull them down or pulls down the Docker image and then just starts doing things.
Yeah, so I don't remember which workshop he was part of. If he was part of one of the early ones, it was a little bit chaotic.
No, I don't think he was part of one because I think he lives in Asia somewhere, but he just said he had heard about it or he'd watched some videos.
Oh, cool. Yeah, we've exposed, I think Seattle we exposed. It just basically comes down to, if I can get someone to videotape it, and then, and then can I follow up with them to actually push it out there? So, those two are surprisingly difficult to do. But yeah, the Seattle one of my friends had all the equipment and everything, so pushed it out there. And the sort of early, very well for the Smack Stack one, for example, it was a pretty small image at the time. Now there's a lot of data sets, a lot of different data sets that we cover because it's become more and more data science-y. And these like TensorFlow data sets are just huge, right? The inception model and things like that. These are not light, these are in the gigabyte kind of range. So, each person, though, so in the early days, I used to have everyone install it on their laptop, right? And it was the old Docker that required VirtualBox and all these shims and everything and all kinds of weird networking.
Oh my!
Yeah. So
and then so just so people know that what is in this stack of technologies, like how many things are?
Yeah, the full playground. Like I said, this is my playground. So
right.
Yeah, there's obviously stuff in here that we don't cover during the workshop, or I'll at like lunchtime I'll have people come up and ask me questions about different things. But so Pancake itself, actually I have to remember myself because I always forget. It's P is Presto. So what was it? Well. Yeah, let me just go through the acronym. P is Presto.
Netflix is big on Presto,
They
by
are,
the way.
Yeah, that's what I was going to say. And not until I started seeing more and more talks and talking to more and more of my friends back there, they love Presto. They prefer it to Spark SQL. It's just, it's different use cases, right? But what they're starting to do is use Presto for their ad hoc queries, right? So these are queries that if they fail, if a node fails, that's fine. They'll just rerun the query, right? Yes, obviously, if you aren't taking into consideration fault tolerance, right? Yeah, so Presto doesn't really care about fault tolerance right now, the version that they have. They just run the query and it's blazing fast, right? So Spark is more generic and does care about fault tolerance, so it has to do checkpoints and save temporary files and things like that, and make sure it's like saving lineage for the transformation, so it can go back and restore an entire node partition, things like that. So Spark, ends up being a little bit slower for the sort of ad hoc case and better for the ETL or the machine learning generation. So so they use Presto more during the day, right? So that's the P there. A I think is Twitter Algebird, or I have a bunch of A's. I think Apache Arrow might even be in there. I started running out of. N is NiFi. Yeah, have you talked to anyone about NiFi?
I have not. That was the first time I had seen that when I was looking at your diagram with all these different technologies. Yeah.
It's bigger on the East Coast, especially when I go to DC. It came out of the NSA. I think 3 or 4 guys came out and started this.
It came out of the NSA? This is a piece of technology that came out of the NSA?
Correct. And I think it's 8 years in the making. There's a really nice UI for it. It stands for Niagara Files, and the sort of master use case that I always reference because I think it paints a pretty good picture is picture like the president, right? He's rolling around in his big probably Cadillac, whatever he has, and he's trying to figure out where to go. The driver's trying to figure out where to go. Is it just maps that he's looking at? No, it's going to be maps. It's going to be crime. It's going to be current events happening. Things there's a whole ton of sources coming in. What's confusing about NiFi is people think of it sort of like a stream processing flow, but it's more like it's sort of earlier in the flow, and its target is Kafka, right? So, these are like mobile devices, things like that can like gather all this information. And since they've open sourced it, they've gotten more friendly with like S3 and or like HDFS and or like normal things that are really more like open source and more really generally accepted than what was going on really behind the scenes at the NSA. So. It's sort of a data collector. People want to make it sound like Spark streaming and can do this complex, processing and all that, but that's not what its main use case is for. It's more to just do routing and things like that. So I think the Hortonworks guys have been so Hortonworks ended up buying this company that was formed out of the NSA. The creators of like NiFi. So I think they were only a separate company for about 6 months, and then Hortonworks picked them up pretty quickly. So
wow, okay, I need to do a show on this.
yeah, I can get you in touch. Joe.
Oh, that would be great.
Yeah, man.
That'd be great.
Yeah.
So I want to talk a little bit more about Pipeline IO because that's what you're working on. So I'm looking at this model, this diagram of all the different things that you cover in the workshop. So it's basically like this. Basically, it's this workflow of how data gets added from end users, basically to your data storage somewhere, and then on the other end, you have data scientists and data engineers that are building models based off of that data, and then that data gets served back to the end users as recommendations. And then throughout this process, you've got machine learning training and streaming data analysis, and you've got pictures of all these different technologies and how this architecture fits together. I think it would be too complex to discuss over a podcast to cover everything. But throughout this diagram, you have these little places in the diagram, in the workflow, where it says Pipeline IO. So Pipeline IO is this company you're working at. What is Pipeline IO contributing to this workflow of getting data from users and serving recommendations? What is the technology that you're building?
Right. Yeah. So there's two main things that we're focused on. I think the diagram that you're looking at has 4 boxes, right? That's kind of highlighted. Yeah. So the end goal is to just have continuous deployment, right? Of these machine learning models. So it's not just recommendations, but could be decision trees. We're obviously talking to some of the bigger companies that are doing fraud detection and like network, like packet analysis, that kind of thing. So they have huge trees. They're starting to ask a lot of questions about TensorFlow and how do I get TensorFlow in here and like continuously deploy. So what's interesting is that there's companies like, so Capital One actually had this really good talk this week at Strata, and then companies like Uber that have continuous deployment for their machine learning in place. And picture it where the data scientist has their say that they're using like IPython. They've gone through, they built their Spark model, built their TensorFlow model. They then commit that model into GitHub, and then from there, just picture Jenkins, for example, which is most likely what we're going to go with. We're looking at a couple options, so Jenkins gets that trigger that a new model has been pushed, and it can package that up. It'll figure out, based on the directory, which, if it's TensorFlow, if it's Python based, if it's, C++ based, if it's Java based, we'll package up the correct version, and then push that. It'll build up a Docker image and then deploy it out as a single canary, right? So there would be one Docker container running right next to 1,000 other Docker containers that are, serving up like the end user. And we slowly start to push traffic to it, and then we have dashboards and metrics and things like that the data scientist can see themselves. So it's not a throw it over the wall. It's I've committed this thing, give me about a minute, and then here's this link to the and showing the canaries prediction performance versus the current 1,000 cluster, and just sort of keep an eye on these things. We're also giving them system metrics, right, like things like that, so they can make sure that if it's right, like JVM, it's not going to blow the heap and things like that. So So that from a pipeline standpoint, that's where the name Pipeline IO comes from. Is that we want to give them continuous pipeline.
So that's awesome, because there's obviously so much discussion about wanting to get continuous deployment throughout the organization, and so how are companies adopting this? Like, are they I guess a better question might be, how are people doing it before? Were they just doing these like very manual processes where they deploy one of these containers and then they just like slowly route traffic, and somebody has to spend their entire day doing this?
For sure, yeah. And the biggest complaint too that I hear is that the production environment is different than their local development environment. So, and I think probably the diagram that you're looking at has a little X in front of the like production
the data
engineer.
engineer. Yeah. No, production engineer, right.
Right. So that's kind of we're trying to get rid of the hand it over the wall and just sort of automate all this, right? So we've also been playing, so we're doing code generation for the JVM and for C++ as well. So we can actually take the Spark, like that Spark model picture decision tree, for example. We can get those decision points from that model, and then it's super easy to just generate trees, right? It's just a big if statement. There's ways to collapse it and further optimize it, but to actually get just the straight up code generation, that's super easy. And so that sort of takes that sort of brute force, or I guess kind of manual step of this production engineer having to code in these weights into the linear regression, or these decision points themselves. So let me just look here real quick. So the way that they're doing it now, they hand it over the wall. It's slow, clunky. The production environment is different potentially. So this production engineer, even his local environment or his test environment might have a different version of SciPy or NumPy or whatnot out in production. So with these new Mac, like Docker for Mac, Docker for Windows, and things like Kubernetes, like Minikube, right? That's where you can actually run a Kubernetes locally. Yes, you can have the exact same environment locally, and then just sort of point it to the production cluster and say go, right?
Now, are people going to the workshop and then they're learning about the PANCAKE stack, or they're learning about whatever technology they work with in the workshop, and then they go back to their company and then they deploy that, and then they just go off on their own and they spin up their own PANCAKE stack, or is it like they experience it and then they start to implement fractions of what they learn in the workshop, and then maybe they get the idea for pipeline. They get the gist of pipeline in the workshop, and then maybe they start to use pipeline at their company. Is that kind of how it works?
Yeah, pretty much. I mean, a workshop is meant to sort of get people thinking. Yes, people always come up at break and say, "Oh, yeah, that's the exact problem that we're having right now. This is great. Yeah, I can't wait to see how you solve it." Or so I think the big takeaway, people from HomeAway, for example, it's it's this company is similar to Airbnb, based out of Austin, Texas. They came, they took away some of the NLP stuff that we demo, right? And then some of that locality sensitive hashing, some of the approximations, things like that. So it just depends on what people are struggling with. And it's not really, I mean, yes, obviously it's one single Docker image. It's all configured to localhost, so I can kind of cheat that way. It's not meant to be pushed out into production and completely scale out. That's actually something we've got tasks that are ongoing about that, sort of breaking up this monolith into something that can scale, right? So, but yeah, and then the other big thing people tend to come away with is how to do this continuous training, right? So yeah, that's the other little box where I think you're seeing pipeline IO is taking data straight off of Spark Streaming, these like mini batches, and or like using stochastic gradient descent on the current current matrix. So these like item vectors, right? And then you have user vectors, and then just sort of making small little changes to those. So like throughout the day, you can pick up trends and, things like that. So just having that flow in place, like people might not want to use those exact same algorithms, but they can now sort of like grok how this all flows together and then how it ends up going out in production and things like that. So.
All right, Chris. Well, this has been a great conversation, wide-ranging, and I find the Pancake Stack very interesting. I find your work, your talks are quite fascinating. I encourage people to check them out at advancedspark.com or pipeline.io. Thanks for coming on.
Cool. Yeah, man, we have fun. We at the very end, we always spin up a really big cluster. So each person gets their own, like typically GCE. That's what I've been using. Each person gets their own 8-core, 50 gig RAM instance, and they're completely isolated to that instance. And at the very end, we take all of that horsepower and that memory, and we make a big, huge Spark cluster. So I think there's some like videos out there of this, but half a terabyte. So half a terabyte. I think we had like, we had 800 cores, something like that going on. So, yeah.
So how many years do you think it'll be until GCE is in wider use than AWS?
Yeah, from
20, 15? I think 15 years.
15 years, yeah. Google's going at it pretty aggressively. I think they need to sort of beef up their, public-facing side a little bit and go beyond just the 2 or 3 people that they have evangelizing. But it's tough because a lot of people have, they're starting to use more Lambda and things that are right, and like Kinesis and things like that.
But Google's got the data flow and the Kubernetes stuff, which is like, and the TensorFlow stuff. That seems to me like a more compelling long game bet than Lambda. Lambda's great. Yeah. Lambda's interesting. Kinesis is really interesting, but I'll take my data center as a service over that any day, I think.
Yeah, what's interesting is Kubernetes 1.4 came out this week, and they've got more and more. It's still in like alpha phase, but like you can see kind of where they're going, where the community's going, which is hybrid cloud, right? So
without Docker.
Yeah, so like with Docker, like with Kubernetes, basically just treat them just like data centers, right? And then on premise as well, so you can actually go really anywhere with these things. So yeah,
totally. Well, what I meant was like it sounds like the Docker constraint is getting factored out, and I don't know, maybe we'll see Google's own container.
Oh, gotcha. Yeah. Right. Gotcha.
So anyway, all right. Well, that's for another show. Clearly. Chris, it's been a pleasure. Hope to meet you in person at some point.
Excellent. Yeah, me too.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.